Okay, in this tutorial I'm going to show you how to run a simulation with SHSAM. In the previous video we downloaded and installed SHSAM on our machine, but in this one we're going to run a simulation. So I'm going to show you how to actually use this thing. So I go into my start menu and I created a shortcut for SHSAM in my start menu. So here it is, bar SHSAM. Let's resize this so you can see this a little bit better. Okay, so this is the main screen of SHSAM. You see a File, Tools, and Help menu. I'm going to walk you through all of these today. So first go to File, New. This is how you create a new file. And the basic setup of this program is it's kind of like a tab-based program, starting at acknowledgements and then kind of going 1 through 8. Those are all the tabs. And in each of the tabs you need to enter some sort of information, otherwise the program can't run. So this first tab, acknowledgements, this just kind of talks about who made the program, that kind of thing. The first one is the introduction, and you don't actually have to enter in any information in the acknowledgements and introduction tabs. But this is just where you can learn more information about the program, how it works. If this is your first time using SHSAM, I definitely recommend reading this help button within the introduction. This talks about SHSAM's concepts and how it works, how it calculates runoff, that kind of thing. I also have another video in this tutorial series that talks about a lot of these concepts too, if you want to go more in depth in them. Okay, so this is the first tab. Number 2 is the first tab where you actually have to enter in some sort of information. And on this tab, this is where you set the root directory, and that's where all files are referenced and where all output files will be placed. This is a really important sentence here. The root directory should not contain any spaces in the folder names. So for example, I like creating a folder on my C drive, so within computer, C, and I call it outputs. So you can see that this is my root directory, C:/outputs. Now let's say that I chose a different folder that was called, like I have one here that's called Canton, Georgia. Let's say I had a project folder I was doing a project in Canton, Georgia. So I'd hit OK. SHSAM doesn't like this because there's a space in here, and if I tried to run the program, it would actually crash. So make sure wherever you place the directory, there are no spaces anywhere in the file pathway. It's not only the last folder that can't have a space, it's anything else in the pathway too. So I really like to do this. Outputs on my C drive. Do what you like. So move on to the next tab. This is the BMP tab. This is where you select which device you want to use. So let's say that I'm working on a project and I already know that I want to use, or let's say that I'm considering a SAFL baffle versus a storm scepter, something like that. Let's say that I'm going to start my simulation using the SAFL baffle. So a standard sump with the SAFL baffle. So I'll click on that. The first window that pops up is, would you like to incorporate washout? So it says that basically all of these different devices were tested in laboratories, and washout is what happens in some of these devices during intense storms. Basically the whole point of these devices is to capture sediment, and a lot of them are good at that, but during intense storms some of them can lose sediment just due to really high flow rates. It can wash out some of that previously captured material. And SHSAM's able to model that washout. So it's asking, would you like to incorporate washout? And I say yes. The next menu is, do you want to use a bypass? So in this design, I'm not going to be using a bypass. So I'm going to say no, but if you wanted to, you'd say yes. And then you say, at what flow does the bypass start? Do you have a weir or something? You should be able to know what is the maximum flow that you're allowing through your device. So I'm going to say no for this simulation. Now the next screen that pops up is these are all the different device sizes that will be tested or will be simulated. So right here we have model, like a model number, and then the pipe size coming into the device. So what's 42, what's 44, all the way to 106? Well, 42 for this device means it's a 4-foot diameter structure. So, this is a cylindrical shape, so the diameter is 4 feet, and the sump depth is 2 feet. And sump depth is the depth from the bottom of the outlet pipe to the bottom of the structure. You can see there's some volume in here. Well, SHSAM is testing a device with 4-foot diameter, 2 feet deep of sump, all the way up to 10-foot diameter, 6 feet deep. So that's a pretty big device. And for all of these different devices, there are different pipe sizes. And you can change these if you like. Okay, so I was happy with all those default values. So now we're done with the BMP tab. Go to tab number 4, Weather Station Precip. And basically SHSAM needs 15-minute precip data to generate its storms and its runoff quantities. So you can go to this drop-down menu, and this is where you can select an existing precip file that's already in SHSAM. So if you can find an area that's close by in your part of the country, go ahead and use these. They've been checked, they're reliable, they're good. So let's say I wanted to do one in Golden Valley, Minnesota. I have some SHSAM has some files loaded in that tell you how much data it has. So it has 15-minute precip data from 1995 to 2007. So that's a good amount of data, 15-minute rainfall data for that amount of years. And that will dictate how long your simulation is. Now there's a good chance that when you go to this drop-down menu, you don't have one of these drop-down menu precip files doesn't match the rainfall that you get in your area, and I'm going to be releasing a different video later on in this series that talks about how to input custom rainfall data, but we're not going to address that in this tutorial. So we're done with that tab. We'll go to particle size distribution, and this is the distribution of particles that will be running off of your watershed. So you go down to another drop-down menu, and you can see you got road sand. You might be familiar with NJCAT sediment, NERP sediment, OK110. If you select one, you can see that this little diagram on the bottom right changes to show you what that distribution is. So this one's kind of like this. It's more of a mix. This one's just pure, a lot of sand. And JCAT, NERP. This one's more fine. Then OK110, median particle size of about 110 microns. Alternatively, you could enter in custom data here inside of this menu. I have another tutorial video in this series that shows you how to do that. For now, we're just going to ignore that, and we're going to use something in our drop-down menu. So let's say we really want to use NJCAT sediment. Next, so we're done with that tab. Next, we'll go to Watershed Data tab, and this is where we kind of build our watershed. So the first thing we can do is enter in the number of acres that drain into the device we're simulating. So how many acres are draining into this SAFL baffle? Let's just say 3 acres. Percent impervious, let's say it's a more urban area, it's like 90%. Hydraulic length is kind of the length of the path through the watershed. A lot of your modeling programs will calculate that for you. So let's say it's 700 in this case. Average slope, let's say it's like 1.5%. And curve number of the pervious area on the watershed. So of the 10% that's not impervious, what is that curve number? Let's say it's 80. Okay. Now temperature file. So the first thing it asks you is, will you be using a standard water temperature of 68 degrees Fahrenheit? I'm going to say no, because water and air temperature do affect how the device performs. It kind of plays with settling velocity and a couple other things too. So you can see here that there are a number of drop-down options in the menu, and since I had picked Golden Valley, Minnesota, that's in the Twin Cities, I'm going to pick St. Paul, Minnesota. This is data from 1991 to 2007. This is daily temperature data. Okay. And now in the final tab here, you have to input the influent concentration of suspended sediment. So if you were next to, and you're kind of guessing here, because we all know that during storms, influent concentration of sediment will vary. Well, SHSAM isn't exactly able to model that, so you need to take a guess for the program. Let's just say 200 milligrams per liter for now. If you have some data from urban watersheds in your, or from watersheds in your area, you might be able to take a better guess than this. In general, we see ranges between 50 milligrams per liter, maybe up to like 300 milligrams per liter. But it really depends on your watershed, and you might need to do a little bit of research to make a good guess on this. Honestly, this is the probably most unknown part of any information you'll enter into SHSAM. So I recommend kind of doing a sensitivity analysis on this. So don't just enter in 200 milligrams per liter. I recommend trying something like, well, how does it perform at 50 milligrams per liter, and how does it perform at 200, and then how might it perform at 400, something like that. At the end of the day, influent concentration doesn't tell you what percentage of sediment your device will capture. It tells you what load of the sediment it will capture. So this more impacts how often you have to clean out your device, not whether or not you meet TSS removal goals. Okay, so we'll stick with 200 here. The next box says, do you want the program to keep track of a number of sump cleanings per year? We're saying yes, we want to keep track of how often somebody has to come in with a vacuum truck and clean it out. Basically, if the program detects that your device is full, it will automatically clean it out. So we hit Run Model, hit OK. It says go to Tools, Output Data to see the summary. Tools, Output Data. Go to Summary, and it shows year by year how well all those different devices it tested performed. So we see that 4-foot diameter, 2-foot deep model, all the way to the 10-foot diameter, 6-foot deep model. And you can see the smallest model captured only 5% of sediment, whereas the largest one captured about 50% for this watershed with this particle size distribution. The program also keeps track of what was the total loading from the simulation and how much of that load was captured and how deep was the deposit in the sump at the end of the year. The program automatically cleans out the device at the end of the year. As you can scroll down, you can see how it performs throughout the simulation. And at the bottom is a summary of how it performed over the entire simulation. So from 1995 to 2007, what was the total load that went through all of those years, and what was the total load captured over all those years? And you can get a removal efficiency from that. These other tabs you can go into more detail on, but they talk about individual sizes of sediment that were removed throughout the simulation. You can create a chart for runoff and removal as well, and you can drop these into your report. You can export all of this data into Excel.